So friends, over here we have a very important example of solving character tables and a very fundamental concept of the group theory. So over here you can see we have the character table, and as you know these are the Mulliken symbols, and this is the whole character table for the C3V point group. Okay, and this is a reducible representation given. These are the irreducible representations, this is the reducible representation. The question is the irreducible components of this reducible representation. So we have to find that out. And the formula for this is this, where H is the order of the group, G is the number of times the symmetry operations occur, xt you can say for the character of the reducible representation, and xi character of the irreducible representation, and we'll just show it how it's done. So this reducible representation has components in all these three irreducible representations. All we have to find out is how much of the component is there. Okay, so we have some options given, and so let's find it out. So the component of the reducible representation in A1, suppose A1 is equals to 1 by, so H over here is the order of the group, which is E is 1, here it's 2, here it's 3, so it's 1 plus 2 plus 3, it is 6. 6 is the order of the group. And first we have seeing it for E. In E, the reducible representation of A1, the reducible representation is 6, right? And over here E occurs only once, so G is 1, reducible representation is 6, and the irreducible representation is 1, so over here we have 1. Similarly for C3 now, right, it occurs 2 times, so over here we have G is 2 for A1. For reducible representation we have the value is 3, so into 3, and in A1 we have it is 1, right? Similarly for sigma v it occurs 3 times, and in reducible representation is 0 the character, and in irreducible representation it's 1. So all over we have 1 by 6, over here 6 plus 6 plus 0, which is equals to 2. Next up we have for A2, sigma A2 is equals to similarly 1 by 6, E occurs once, for reducible representation the character is 6, for reducible representation of A2 now it's 1, right, plus for C3 it occurs 2 times, for reducible representation the character is 3, for A2 it's 1, and in the end we'll be having 0 again, because for the character of the reducible representation is 0, right? So regardless of the character of the A2, which is actually -1, we'll get 0. So over here we'll have 6 over here and 6 over here, so again we'll be having it as 2, right? And finally for E, let's find it out. So again we have 1 by 6, and again E occurs once, the character for reducible representation is 6, character for the irreducible one is 2 now, right? For C3 it occurs 2 times, the character of the reducible representation is 3, and for the irreducible one it's -1, and again in the end part we'll be having 0. Okay, so this is 12 and this is -6, right? This whole is -6, so we'll having 1 by 6, 12 minus 6, which is 1. So we can say this reducible representation is E plus 2A1 plus 2a 2. This is the components. It matches with our first option. So that's done. Another type that we can have is which transition is allowed. Okay, so from this, so only those transitions are allowed which are polarized in the x direction, y direction, or z direction. Okay, so what do I mean by that? So suppose we have a transition from A1 to E. Okay, so what we do is just multiply the characters of both A1 and E, and if we do that we will get, actually say suppose 1 1 1 for A1, for E we have 2 minus 1 0, and so the answer of this is 2 minus 1 0. So this, as we see in the character table, is actually polarized in the x direction and the y direction. Or but if we say suppose A1 to A2, over here we have 1 1 1 1 1 minus 1, and the answer to this is 1 1 minus 1, but this is not polarized in any direction, so this is actually forbidden. Okay, so this is very simple. Here just multiply it and see whether it has some characters over here or not. This is actually Cartesian coordinates signifying in which direction is polarized. So sorry for that. Okay, sorry for that. And so if it's polarized in one direction, it's good, otherwise it is forbidden. So that's it. So we just discussed, this is the very fundamentals of uh, the group theory, how to find out the components of the irreducible representation, right, and whether a transition is forbidden or allowed.